Okay, so yes, I am. All right, so good evening, everybody. Um, my name is Sumayah Adegbite, and I am a second year math major at the University of Lagos with a growing passion for AI, either research or engineering. I've not decided. I'm currently like exploring both options. Yes, so and I'll be taking you on the fundamentals of machine learning. So let me just share my screen. Sorry. First start my video. Sorry. So can you see my screen? Hello, sorry, can you see my screen?
Yes, I can.
Yes, yes.
Yes, I can still see.
Okay, so I guess we can start. So like I said, I'll be taking you guys on the fundamentals of machine learning. And for a start, so like it's going to like be in two ways. I'm going to first do like a bit of introduction to ML, then finally to like the workshop. Okay, so like what is machine learning? So machine learning is a type of artificial intelligence where computers can learn from data to make decisions, predictions, or classifications without being explicitly programmed. So from like the name, like machine learning. So literally like the machine is learning. So from the name, and instead of writing like detailed instructions, we use to like so we have different types of machine learning, and for this we have the supervised learning. That is when the computer learns from labeled data. Okay, so and that is literally when you want to train your machine, then you are training your machine with like set of objects. Then as you're training it with this object, you are telling it, oh, probably like give it a picture of a cat, and you're like, oh, this is a cat. So that's the data that's like labeled, and that's like a form of supervised learning. You know, when you do something like under supervision, that means you are being guided and you're being watched over. So something like that. That's like literally supervised learning. And we can see it like in real life examples. For in the case of like email spam detection. So we train like our ML models to be able to recognize like certain keywords and certain like let's say subject senders, and you're able to like know, oh, then you notice like Gmail has like this message tells you, is it not report spam or something like that. Actually, like if the sender probably sends you through an unusual way, sends a mail like an email through an unusual way. So like the Gmail tells you, oh, this like flag it spam something. So that's like an example of like supervised learning. Then we have the next type of machine learning, which is unsupervised learning. So that's literally you're training um when something like is being trained without like supervision. So the computer learns from data that has no labels. Okay. Instead, it's able to identify like structure. For example, probably like you fed the computer with like a collection of like different animals. Okay. So the machine learning itself is able to like, let's say, guess, oh, probably if an animal has four legs, then it's most likely going to like be a mammal, something like that. So unsupervised learning. And then we have the reinforcement. Okay, so a real life example of unsupervised learning is um customer prediction. Okay, so that's literally, when you're shopping on Jumia, and then probably you've always shopped for products like phone related products or electronic devices, but then suddenly probably you try to like get that type of, so the machine has recognized that you always shop phone related like product, but then there are some times whereby you don't want to actually get phone, you want to get something else. So for the machine to like be able to adjust, that's like the unsupervised learning there. Then we have reinforcement learning. So like it's written on the screen. This is a bit like learning by trial and error. Okay. And that's like when it's depending on the feedback like you give it, it learns based on that feedback. So imagine you're teaching like a robot to walk. So in that process, even though you might teach like the robot to work a particular way, but when it begins to actually like put it in practice and begin to work, then it would actually like learn, how do I do this explanation? So it would, because like we all have different types the way we work, and that's like the same in the case of robots. So it, like as it begins to like work and it's able to, especially when it gets like being able to detect objects and all, or it's not as, oh, I have to turn, I don't have to like keep walking straight and all. So that's like reinforcement learning. Hope I'm not missing anything. Okay, yes. So, and an example of reinforcement learning, like in real world, is self-driving cars. So, self-driving cars are able to like detect when there's an object in their way to avoid, like, say, collision. And even in the case of traffic rules, like a self-driving car should be able to stop when when the traffic light like turns red. And the only way it's able to learn it's like actually through trial and error. Okay. So these are other real world applications of ML, machine learning. And this is like just some of them. So ML can help doctors by predicting diseases like cancer or heart disease from like medical images or patient data. ML is used to support unusual activities like in credit card transactions, helping detect fraud. Probably like there's an unusual activity going on with probably like your credit card. Because like let's say when there's some sort of attack or like fraud detection, the way the transaction like happens is different from like when you're using your card like personally. So ML is actually able to like support these activities. Then we have voice assistants like Siri or Alexa. So I'm sure most of us we actually know Siri. I believe most of us we know Siri like what this called, or Google Assistants. So they use ML to understand your voice commands and respond accurately. Like you're telling Siri, "Oh, please send an email to Chinedu," and it's able to like it opens up your email, then it's asking next, okay, what do you like me to send? And like these are real world applications of ML. Then ML is used for security systems. So where the system learns to recognize faces in images of video feeds. And I think like we have smart doors. So a smart door, the smart doors actually have like category. We have those we have some smart doors whereby they actually unlock depending on probably like the user's face. And we have some that just detect automatically like if it's human and it opens up straight. So like so these are rewards applications of ML. Yes. So I guess that's literally it, the introduction to ML. And now we should be heading to the workshop. Hope I was not too fast. Okay. So for the workshop, hello, sorry, can you guys hear me?
Yes, you can.
Yes,
Yeah, I can hear
yes,
you.
we can hear you.
Okay. So for the workshop, we're actually going to be doing a little project. It's actually not that complex project, which you guys can actually like follow along. So if you guys have probably Python installed, or you can actually use Google Colab. So go to your browser, search for um Google Colab. Okay, please, if you guys like are there already, can I like just know? Okay, is anybody saying anything?
Did you say something, Smile?
No, like I was like are we on our Google Colab? So I can know if I can proceed or not.
I think
Or
you
should
can
I
go
just
ahead.
continue?
Yes, yes.
Okay. So for our workshop, like I said earlier, we are going to be doing something on classification. So the reason why, and classification is such like a huge importance like in ML, because these AI systems that we're building, they're learning from data, and bad data, bad results, or poor data, poor results, good data, good results. So no matter what system you build, it all boils down to like the data that is being used, and being able to classify, depending on the type of like project you're working on, you want to be able to like actually classify your data based on either like using like the features. Okay. So for example, now let's say you have a mixture of my, my favorite examples. You have a mixture of like apples and bananas. Now in that case, if you actually want to separate, you need to find something like common and is best used, a feature that is common in both of them that is best used for like separation. Okay. So probably when the redness, when the fruit is actually like red, then you know, oh, this is like apple. But then sometimes you can actually have red oranges and all. So like the project we're going to be working on now is we're going to be doing something related to classification, and also knowing determining what sort of feature is like the best to be used like for the classification. I don't know if like you guys get. And for that, we are going to be using a data set. I remember when I started ML, I did introduction to ML. I said something about like ML, you're literally learning from like data. Okay, so like data is like very like vital, like in machine learning. And for this simple project, we're going to be using the iris data set. So it's actually like the iris data set is a great starting point for like in machine learning, because it's actually small, well organized, and easy to understand compared to like using like huge large data sets. So by the end of the workshop, we should actually be able to do the same thing that we'll be doing. And it provides an opportunity for like us to explore classification tasks and also visualize. So depending on the data we get after we actually like visualize, that's what will make us like determine um like the best ML algorithms to predict the species of iris flowers based on their sepal and petal measurement. So this iris data set, like this image you see here now, this iris, hmm, even though I did not really like biology when I was in school, but you know, we have this thing whereby we are like family, genus, species, like for the science students here. So that's something related to like this iris data set. So this iris is something like a family. I don't know if that's correct. Probably the medical students or those that do something related to biology. So like this iris is probably like the family. Then it has like different children that like fall like under it. You know the same way we have cat, tiger, lion. They're all like under. I don't know. They're all under cat family, something like that. So that's how this iris data set too is. So and for this, we are going to be trying to predict um using three of this family, and that is Sitosa, Versicolor, Virginica. So they're actually all under the family Iris, but then they have things that distinct them, their length, their width. So the sepal length, the sepal width, and the petal length with the petal width. And that's what we are going to be using to determine, which is this, and which of the features is actually the best to be used. Let's say when we actually want to classify that's okay. Each flower in the data set is labeled with one of these species, and the goal of ML models trained on this data is to predict I forgot to add the flowers image. Okay, so the goal of this workshop is to introduce the fundamentals of ML using a simple classification problem. We are training a model to predict the species of an Aries flower based on its measurement feature selection. Choosing the right inputs for prediction. Choosing the right inputs for prediction, data model information. So literally what I've explained. And for a start, hello guys. Am I still on the call? So we are going to import our libraries and also our data using this. And I think I'll just write that I'm coming. Pretty long. So in your Google Colab, we want to start off by importing like our libraries, and we are going to be importing a NumPy like and pandas for data handling and numerical like operations. So import, sorry. Then I'm also going to import because we actually want to be able to like the Seaborn too for like visualization. Okay, yes. So now the next thing we want to use is we want to be able to use to load our data set. So because like our data set is a simple one, we are not actually using cargo like in the previous example. We are not using cargo. We are using Sorry, hello.
Hello, I can hear you. I can hear you.
Oh, I did not even know that I left the call already. Sorry, I'm trying to share my screen. So I'm just trying to like import like everything that's needed for the project. I'm coming. It's going to go pre-processing. Okay, I think let me. I should actually show the screen. The screen of the slide for those who love to follow along. Sorry.
I think Sumaya is having some issues, so we can just wait a bit.
Okay, good evening, everyone. Can everybody hear me? Good evening. Can anybody hear me?
Yes, yes, we can.
Okay,
Yes, 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 yes.
okay. All right. I trust we're all doing good today. So yeah, since I think Sumaya has some issues with her network, I guess. Let's just have like a bit of discussion while we wait for her to join the call back. So let's talk about I know this is an ML workshop, so okay, I think she's back. All right. Sumaya, welcome back. I am muted. Sumaya, unmute yourself.
Sorry.
Okay, thank you.
Etta kicked me out. I'm so sorry.
Yeah, no problem. Everybody's facing it those problem. Yeah, welcome
I'm so
back.
sorry. So I'm going to share my screen now. And for those that are following along, I believe like you should be done. By now you should have imported like the libraries and can you see my screen now? Hello, can you see my screen?
No, we can't.
No, I can't see.
Ha. Okay.
Sumaya, we can't see your screen.
Okay, that's what I'm trying to see what's wrong.
Okay, so I think I'm going to continue. I think Sumaya, let's tell Andawala. Okay, so
Yeah.
let's okay, she's back again.
So I'm so sorry. I don't know what's wrong with network today. So please, can you see my screen now? Okay, so the network issue again.
Yes, we can. We can see your screen.
You should have like imported I don't think they can hear me. Okay, you can see my screen. Okay, so now the next thing you want to do is you actually want to load um you want to load the data set, and then literally this load iris. I don't know if that's like when I was explaining the other time. So this load iris is like what fetches the iris data like the other time. And then we create a data frame for easy viewing. And that's why like we have this PD. So this PD is from like the pandas let's say package that we imported the other time. So let me just go to my code and also like write that. So like for those that are following along, please just do this. Okay, so for those can't even hear me. Hello? Okay, yeah, can you hear me? Sorry. I'm just gonna see my screen then. Okay, so now the next thing we want to do is the data. We actually want to after we've loaded like our data sets, the next thing we want to do is we want to like be able to visualize. Yes, we want to be able to visualize what we've done. And if you notice, like we already imported like the list of things that we needed. Okay, we already imported the list of things that we needed. And for those that are like following along and running it, you would see after like you run it, you can see like some values. The sepal length, sepal width, petal length, the petal width, and like different values. Then you see like target and species. So that's what we're going to be viewing now, but then like in a graph like format. And yes, I think that's the slide that I'm on. So this is what we're going to be writing. So please let's write that out for those of us that are like following along. So once you visualize the data, please if you guys have any issues, please let me know in the comment section. Okay. So now after doing that, you should see. So sorry, please, can I have a show of hands for like those following along? I want to ask what actually happened after this step. Okay. So Sadiq Teslim. So what do you see now?
I'm actually still writing the code.
Wait, which of the code? Is it the visualization?
Yes.
Okay. You got the rest, right? Like did you write
Yeah.
the previous? Okay, okay. Okay, so do that then tell us like what you see. Like after you run it.
Coming. It's saying
Okay, so
connecting.
okay, you're running it. So I think I'm going to
It's saying invalid syntax. I'm coming. Like I
invalid
made a
syntax.
mistake.
Okay, so we which exactly? You should see something like a red is the underscore red line.
Let plt dot show. Oh, plt dot show. I'm having,
Plt dot show.
yeah.
Did you import matplotlib?
No.
Okay, you need to. I'm coming. Let me go back to the first and see like if your imports. So can you check this? This is the PLT. The PLT is like coming from this matplotlib package.
Okay, so how do I install? How do I import that?
No, just put import. Write the import
Okay, okay,
matplotlib.pypilot the same way like it's here.
all
But
right.
just to keep like your
Okay,
code well organized and all, you can like go back to the first cell to write
okay.
like all your imports. Coming. So I just got like an advice to try splitting my screen so you're able to see my code. Come, let me try that. I don't know. I'm not getting this. I'm not getting this thing. So Sadiq, have you imported the matplotlib?
Yes, I have.
So is your code now working or is this still showing errors?
Still showing error, but this time is syntax. So
Syntax
trying
error.
to
Which line?
third line, yeah.
Don't
The
line.
first
Never actually.
one. Someone is raising their hand.
Okay, so um, like, can you go ahead?
So Sumaya, hi. Can you go back to your this thing? What's it called? To your library importation part. Can you share your screen to that part?
All right. Let's have to just that now. Okay, can you see my screen?
Mm, not yet, but it's coming up. Let me see. Yeah, it's there. Thank you.
I'm coming. I want to try the old split screen again. So I want to stop sharing for a while. Still the same. Okay, so this is what my own code looks like currently. Can you guys see my screen?
Okay, but it's not that clear.
What of now?
Yes, we can.
Okay. So now, do you guys have like all the imports now? So NumPy, Pandas, Matplotlib, lib, the Pyplot as PLT. So this as PLTs, we are able to like call them like using this shorting words. The import Seaborn. Do we have this complete? Sadiq, do you have all of this complete now? I still having issues, Sadiq. Is Sadiq still on the
Sumayah,
call?
can you scroll down? Can you scroll down a little bit?
A little bit.
Yeah.
Okay.
So the next block of this now.
Okay.
I've imported all the necessary parts for the
Yes.
next one.
So this is the next. Loading the data set and then visualizing it like using um like seeing it like through a frame using the pandas like library imported data frame. Please, if anyone is trying it, do not forget to also like talk so I know.
Yeah, I'm tying it on my own end here. Let's see. Nice work though.
Okay, has it worked?
I'm almost done. I'm almost done.
Okay.
Sumaya, I was getting a table.
Yes, yes. So like
Okay.
that's the data frame and also like this df dot earth. So this is like a sepal width, petal width, target and species. And then next, like it's all going to make sense next.
Yeah, the last one. I
By
think
the
there's
time
still one
we
block of code left.
visualize it, yes, by the time we visualize it.
Yeah, so that's
So
the where the matplotlib come in place, right?
yes, this PLT to show, yes.
Wait, I should just write PLT dot show, or there's something before
No,
it.
no, no, no. Yes.
Okay. SNS.
So have you completed that? Please, if you are done, let me know. So I can explain like the whole graph that we have here and like
Okay,
what
yeah,
it means.
last I'm almost done. I'm almost done. I'm sorry. No, I'm getting error, but
You're
it's
getting
trying
an
to plot.
error.
It's trying to plot it, but there's an error. It's saying that I think species. I'm playing about species. The hue species.
Species. Hmm.
Mm,
Did it tell you like the line? What line?
That's what I'm trying to get. Okay.
Did you put
Because
like the hue?
yes, I put the hue there.
When you were loading data set, did you put like the df species equals df target to apply? Can you like share your screen?
Okay, I can do that. I'm coming. Give me a minute. Let me see. I have to stop sharing. Okay. Do you know whether you can see my screen?
It's just like trying to come up. Let me try to enlarge this.
Many of the errors I'm seeing, it keeps going back to the library, to the libraries what's called the library package, and currently I
Sorry, can you
think
scroll up?
it's okay, no problem. Yeah, this is the code, this is the code, this is the error.
I'm coming up.
No problem.
Please like scroll up. The way it's in SMS. It's like when you imported.
Oh, okay. Mm.
Processing. Okay. Okay. So you see that part where you have target name. That part
Target.
where you have target name. It's meant to be species written there. That part where you have like target name. It's meant to be species. Can you see target name?
Oh, okay. Okay.
Yes, it's meant to be species there still.
Okay. So thank you.
I'm coming. Let me check it. What's
Species.
this am I doing? There is a target name. So run it again.
So on this. Good.
Is it still showing issue? Error.
Mm. Still loading. Yeah, perfect. Thank you.
Okay.
I'm
So now
stopping
it's
this.
now works. I'm coming. Let me. Can I stop sharing your screen?
Yeah. Interesting.
So if Sadiq is still like on the call, can you like just say hi? So I can know like if you're still like having issues.
I don't think he's on the call. I just checked the contact list, the participants list. It's not there.
Oh, okay. So for those like who are following along, you would see like this graph that might look scary, but there's actually nothing scary like about this, because like each rows, yeah, and column, they like correspond to like a feature. And like if you look at the sides, you see them here. So this sepal length times everything here, sepal length, no, then sepal width, petal length, then the target. Then we also have sepal length, sepal width, petal length, like on the column also. So now is this visualization here that would tell us like which feature is actually like the best to like use. And we have like diagonal plots which shows the distribution of like each feature. Then we have the off diagonal plots that show scatter plots of like two features at a time, such as like the sepal length versus the petal width. And we have the color coded by like species, which you can see how each species, the Setosa, vesicola, and virginica clusters that I mentioned initially, like how they have. And come on, let me try to reduce this. There's also something at the side. Yeah, so the blue is actually representing the Setosa. Then the vesicola is being represented with this gray like color, is it ash? Then the virginica with this yellow orangish like color. So now we want to look for like clusters that are for clusters or like overlaps. So if you see like distinct let's say groupings for each species, there is a sign the features can separate them the most. Remember when I first started, I started like the analogy of, let's say you want to separate apples and bananas, then you need to like you want to know which feature is the best that can actually do that. Is it a color feature? Are we using like colors to determine the separation? Probably like if it's slightly close to like a certain RGB that is close to like red, then we know, or we flag it as an apple. And if it's like close to like yellow, then we flag it as probably like the other fruit. So we want to be able to like know these features. And it's a pity I forgot to like add the three diagrams of actually these three different flowers. But like if you guys actually like check on it probably like after the call, you would even notice like Setosa is like is much different compared to like the rest. This versicolor and virginica, they almost look alike. And that's why like you see most of these plottings here, they're actually like almost together. The versicolor and the virginica, you see they're almost together. Why the Setosa is like much separate. And this tells us like a great deal, because in terms of by the time we have two, by the time we have like this virginica and vesicolor similar, that means whatever we'll be choosing as a criteria for like feature to be able to like separate them must be really, we have to like really think through it. Because if you are not careful, because they are similar, if you just decide to use probably, don't worry, I'm going to like explain like further using like this visualization. And then I'm coming. Okay, so like from this pair plots we have now, we can have like a rough idea of how strongly like each pair of features correlate by seeing how tightly or loosely the data points cluster in the scatter plot generally. So a strong relationship means shows like a clear linear or curved pattern, a clear linear or curved pattern, while a weak relationship appears like more scattered without a clear trend. So literally what that means is, if we look at the petal length and the petal width, come on, where's the petal length? Petal length, then petal width should be somewhere. Okay, so this is the petal width. Sorry. I know some of you might be like, I'm weird that I'm using the white mode. I'm using light mode. But then it's just where it is. So petal width and petal length. Yes. So this is actually the plot. And you can see like you would notice, let me zoom in. So you would notice that this plot is quite, and I'm like it's, will I say, organized. Okay, so these are, it can either be linear or like curved, but like it's clearly defined. Okay, like the vesicular and virginica, like different from like the values. The vesicular and the virginica, their values like almost clashing. Like a plot like this is not, is a weak relationship, because even the whole plotting is like scattered without like a clear, let's say, trend. Yes, without a clear trend. So based like, based on this like explanation, we can actually agree just from like this whole visualization that the one that has the best, or the um the best relationship is this, the petal width and the petal length. So why does even like all of this matter? So like when you create like a scatter plot or pair plot, as we can see here, we can visually see what's happening to determine, to determine the best feature that should be used for like let's say classification. Come in. So by the time we're able to identify how where different species are separated based on their features, then we can now decide which features are actually the most relevant to predicting the species. So like in this case now, the one that has like a strong relationship is actually like the one that is best for prediction. And that's like the petal width and the petal length. That means with the petal width and the petal length, you can actually determine if it's a virginica, it's a setosa, or a versicolor because of like the values. But if we decide to use probably like a plot like this, see, this is even like kind of like overlapping with this. So there's going to like be confusion. Okay, the machine learn, the model is going to be confused. But for something like this, actually distinct, they're all separate, and like it's all clear apart. So, and again, another way again is we could actually like use a correlation. I think we're going to be doing that next. We can use a correlation, and like using correlation like helps us know which features are most important for like a classification model. Then yes, I think that's what it we need to know for like this. Yes, so mhm. So if we go back to the slides, what are we going to supposed to do next? Okay, so the next thing we want to do is we actually want to train and test, like split this data. And whenever like you're working like with data, like in ML, actually like classification problems, it's always important like you actually split your data into training and like testing this testing part. And for like in this case, like the most common cases usually like we split our data like into training, which is like about 80%, and testing 20%. So the training set is what we actually use to teach the model. Okay, we use the training set to teach the model, then we use the test set to check how well the model like generalizes to like unseen data, like data that it has not been trained on before. How well is it able to what's the right word, how well is it able to okay, how well it's able to generalize on like a data that it has not been trained on. And I guess I'll just add that next to my code. So now I want to have next step, just like split the data into training and testing set, and that's the code like on the screen. So like can just copy it.
Sorry, Smile, can you turn your screen to slideshow?
Oh, sorry. Mhm. Okay, should we sit down? So we're almost done with like it's the workshop.
So, Smile, in essence, what we're doing here is we're trying to train the model, right?
Sorry, I did not get what you said.
I'm saying that what we're trying to do here, we're trying to train the model, the machine learning model that we've created, the data set we've created. We're trying to get some specific things from it, right?
And we are trying to determine like the best feature that would be
Okay.
used for like using like a classification um model. Do you get? So like with the visualization now we know if we want to actually do something that if we actually like want to separate want to be able to determine like those flowers, which is the setosa, the virginica, and the rest. The best features like that we can use is the petal width and the petal length. That's like using those as like as a criteria would be the best like in determining like which of this like is a setosa, which of it is a virginica, which of it is the last one. So that's literally it.
Okay, thank you.
So have you done the training and the training the splitting data into training and testing set?
I've run it, but it's not bringing any diagram or table or anything. Is there a next line of code for this?
Yes. Okay.
Okay.
So now next thing we want to do is so now the next thing we want to do is we actually want to do something called like data like preprocessing. And literally what this means is um that's because like many ML algorithms they benefit from like let's say from feature scaling. So you are bringing all features to like a similar range. So using like standard scaler like standardizes features by removing the mean and scaling to like the unit variance. And all of this is just to be able to like improve model performance. That's the reason like we are doing all of this. Even the whole splitting into training and testing for it to like so you know like how good what you're training like is. Yes, because they would always be bound. So hope this expansion is not too advanced. Okay, so the reason why we are doing all of this is let's say like you build a model that's able to separate maybe like um bananas. So ripe bananas and like unripe bananas. But like in real world, there will be some bananas that are actually spoiled and their features like going to be different. So in that kind of case, like how is the machine able to like actually correctly like classify it? So like that's why we are doing all of this. Then yes, so this is it. So what we are training it. We're going to like use this scalar for it to fit transform, extract, then also the testing data too. We're going to do it. Okay.
Do the same thing for the Y, right?
For the
For the
no, just for
Y,
the X.
or just for
Just for the X. Are you done? Let me see. Have I written mine?
yeah, I'm done. I'm done.
Okay. Now the next step is where we actually want to train the model using like some sort of like classifier. Yes. Like what's actually going to do like audio separation and all. And we have different types of like classifiers. And the classifier you use is depends on the like type of data that you have. So we have like linear and non-linear classifiers. That's like a huge topic on its own. I'm coming. I'm trying to finish up my own code. Sorry. And that's like a huge topic on its own. Okay. So for our workshop, I used the what's it called? Yes. So I used the k nearest neighbor, which is like a form of classifier. Yes. So and literally this is how it is. So this K here, so you can say I like have like an hashtag. You're choosing case to five as an example. So you can actually tweak it. So the depending on how you tweak it to you're able to get the best. Oh god, this is actually like like another topic on its own, like classifying. I'm using like all of these models. So you actually tweak it so you're able to get the one that is able to separate it best. Okay. So let's say you want to separate probably like 10 apples, 10 oranges, you've mixed them together. So like using like all these classifiers, it would it would separate it would turn around. So that's why I said we have linear and non-linear classifiers. So linear classifier literally is just imagine like a graph. You know, when you draw something linearly, then it's separating all the points on the right are separate from all the points in the left. And like in real world, that's actually not how it is. You have probably like a red apple that is hiding under the green apple. So sometimes you need imagine a scenario whereby instead of doing something linear, then it's able to like curve k equals to 5 number. That would determine like how it's able to like separate better. The explanation. Okay, so I guess I can just write it. So it's a simple algorithm that classifies a new data point. We can experiment with different values, 3, 7, etc. to see if accuracy improves. So we use it to like make predictions. Once the model is trained, we use it to predict the species for like the test set. While predictions will contain the predicted class for each sample in X tests. Do I have this code? Okay. Network kicked me out again. Hello, can you hear me? Hello, I don't think they can hear me again. Should have protect the network.